Hi everybody, today we're going to look at solving rational inequalities, and there are a number of ways that you could do that, but I'm going to specifically talk about the sign chart method. When we solve a rational inequality, we want to start by setting one side of the inequality to be 0. I think it's best if you do that on the right because we read left to right, so you want to say something is greater than or equal to 0 or something is less than or equal to 0. So our strategy is that if we have a over b is greater than 0, then we know we want a positive solution. If we have a over b is less than 0, we want to have a negative solution. I will talk about what happens if it's greater than or equal to, less than or equal to. Think of them as pairs, so greater than and greater than or equal to will go together. Less than or equal to will go together, but there are differences, so we will pay attention to that as we solve these. So quick reminder, if I have a over b is equal to 0, that's only going to be true when a is equal to 0. So it's just the numerator I look for to get the 0. I also have to be concerned with a over b being undefined, and that happens when the denominator is equal to 0. I didn't write it on here, but at no time are we looking at 0 over 0. Like, that's not part of what we should look at today. So separately, the top and the bottom, we'll set them both equal to 0. So let's start with kind of a small one. I have x plus 2 over x minus 3 is greater than or equal to 0. So I'm going to start with doing those two things I talked about. I'll take the x plus 2, set it equal to 0, which gives me x equals negative 2. And then I'm going to set x minus 3 equal to 0, which says x is equal to 3. So I make a little line. So here's a number line. I put in my 2 points. So here's negative 2, here's positive 3. I'm just going to put a u up here to say this is where it's undefined, just to kind of help myself keep track. Another thing I can do, because I'm going to test the signs, is I'm going to put a straight line under the negative 2. I'm going to put a dashed line under the 3. And that dashed line reminds me, don't use the 3. That's where the denominator was 0. So I like to make intervals. So negative infinity up to negative 2, then negative 2 to positive 3, and then 3 to infinity. Then I like to pick a test point. So you can pick anything in each of the intervals. So let's say I pick like a negative 3, maybe I pick 0, and I pick 4. And what I want to do is I want to test the sign of this number. So that's why it's called a sign chart. So if I put that into x plus 2 over x minus 3, and I will do it the long way this time. So negative 3 plus 2 over negative 3 minus 3. Negative 3 plus 2 is negative. Negative 3 minus 3 is also negative. A negative over a negative is a positive. So I know anything in this interval, negative infinity to negative 2, will be a positive number. Then if I choose my 0, so I do 0 plus 2 over 0 minus 3. So 0 plus 2 positive, 0 minus 3 negative. Positive over a negative is a negative. The last one, I put in 4. So 4 plus 2, that's positive. 4 minus 3 is also positive. A positive over a positive is a positive. So what I said a few slides back is greater than or equal to 0 means I want positive numbers. And I have positive in negative infinity to negative 2. I also have positives from 3 to infinity. Here's a really crucial part is how am I going to write this in interval notation? So I know I start at negative infinity and I stop at negative 2. This negative 2 came from the numerator, so I can do a square bracket to say it's okay to put in negative 2. Then I say union. I go over to 3 and I go to infinity. Now this time, this dashed line that I talked about means I'm going to do an open parenthesis. I don't want to put in the value of 3 because that would make it undefined. So all of this together is my solution. So let's try that again. I'm making it bigger because it's not set equal to 0 from the start. So what I want to do is put everything on the left side. So let's say I have x over x plus 6 minus 1 over x plus 2 is less than or equal to 0. Now when we solve equations like this, I clear the denominator a lot of times. You cannot do that when you're solving inequalities because if I multiply by x plus 6 or x plus 2, I don't know if that expression is positive or negative. It's going to change. And so because it changes, where the x plus 6 and x plus 2 changes from positive to negative, the sign of the inequality would change from less than to greater than. So you don't want to touch that at all. You want to do it a different way, which is to find a common denominator. The common denominator I would have would be x plus 6 times x plus 2. So you should picture multiplying x plus 2 over x plus 2 times x over x plus 6. And then I'm going to multiply x plus 6 over x plus 6 times 1 over x plus 2. So I've introduced now my common denominator. In my first term, I have x times x plus 2, which is x squared plus 2x. And then I have this minus sign, so I want to say minus x minus 6 over x plus 2 times x plus 6. The good news is you are not going to do anything with the denominator. There's not a point where we're going to multiply that out. We're going to leave it alone. So let's simplify here. I have x squared, 2x minus x is plus x minus 6 over x plus 2 times x plus 6. Again, it's still less than or equal to 0. I can factor x squared plus x minus 6. It becomes x plus 3 times x minus 2 over x plus 2 times x plus 6. So this is our starting point. So I'm going to go to a fresh slide and I'll show you what to do with this. All right, so I have this x plus 3 times x minus 2 over x plus 2 times x plus 6. In the numerator, x plus 3 times x minus 2 is 0 when x is negative 3 and when x is positive 2. In the denominator, x plus 2 times x plus 6 is 0 when x is negative 2 and x equals negative 6. Now I'm going to write myself a little note. This is undefined. So I'm going to go to a number line and I'm going to put all four numbers in. So I have negative 6, I have negative 3, I have negative 2, I have positive 2. I have a lot of intervals. Negative infinity to negative 6, then negative 6 to negative 3, negative 3 to negative 2, negative 2 to positive 2, and then 2 to infinity. Remember what I did last time. I said anything that came from the denominator, I'm going to put a dash line in. So at negative 6, I'm going to dash it through. At negative 2, I'm going to dash it through. And then I'll put a straight line and a straight line when I get to the ones that came from the numerator. And that just helps me sort between all these numbers. Now we're going to pick a number in each interval. So maybe I pick like negative 7, negative 4. Between negative 3 and negative 2, maybe negative 2.5. You can always find a number between the two of them. Negative 2 to 2, I like 0, and 2 to infinity, I like 3. So what we're going to do now is we're going to plug them back into this x plus 3 times x minus 2 over x plus 2 times x plus 6. This time I'm not going to write it all in, I'm just going to do the sign. So negative 7 plus 3, that's a negative. Negative 7 minus 2, also negative. Negative 7 plus 2, negative. Negative 7 plus 6, negative. I have 4 negatives, which make a positive. Right, the next one, negative 4. Negative 4 plus 3 is negative. Negative 4 minus 2, negative. Negative 4 plus 2, also negative. But negative 4 plus 6 is positive. 3 negatives stays negative. Let's go to negative 2.5. When I add 3, I get a positive. When I subtract 2, I get a negative. When I add 2, I get a negative. When I add 6, I get a positive. 2 negatives make it a positive. I do 0 plus 3, positive, 0 minus 2, negative, 0 plus 2, positive, 0 plus 6, positive. 1 negative makes the whole thing negative. Let's finish with the 3. 3 plus 3, positive, 3 minus 2, positive, 3 plus 2, positive, 3 plus 6, positive. This is overall positive. So the question now is, well, what did I want? And when I simplified, I said less than or equal to 0, which means I want a negative. So I can see a negative here from negative 6 to negative 3. I can also see a negative here from negative 2 to 2. Notice the intervals go positive, negative, positive, negative, positive. So every time it hit 0, it happened to switch. Will that always happen? No, but it happens most of the time. So our final answer, the negative 6 needs to be open because you can see the dashed line, so I can't use the negative 6. At negative 3, it can be closed because there's a solid line and we're looking at less than or equal to. Then I do union. I look at -2, I see a dash, so I go open at -2. 2 has a solid line, so I can close it out. Let's try one more. This time I have 3 over 3x plus 4 is greater than 2 over 2x plus 1. So this one doesn't have the or equal to, which is kind of easier because that means all of the intervals are going to be open in my final answer. But we're going to start the same kind of way where I want to bring everything over to the left. So I have 3 over 3x plus 4 minus 2 over 2x plus 1, and that's greater than 0. So like last time, I think let's make a common denominator, which will be 3x plus 4 times 2x plus 1. So my first term, I'm going to multiply 2x plus 1 over 2x plus 1 times 3 over 3x plus 4 minus, now I'm going to do 3x plus 4 over 3x plus 4 times 2 over 2x plus 1, and still greater than 0. So let's multiply this out. 3 times 2x, that gives me 6x. 3 times 1 is plus 3. Here, I think of this as being a minus 2 when I multiply, so -2 times 3x is minus 6x, and -2 times 4 is minus 8, and this is over 2x plus 1 times 3x plus 4, and remember this is greater than 0. The -6x cancels the 6x, so I have 3 minus 8, which is -5, over 2x plus 1 times 3x plus 4. And again, greater than 0. So now here's the part that's a little bit different. The numerator is -5, which is a constant. -5 will never be equal to 0, so I don't have a number to grab from the numerator. Absolutely fine. So I take the 2x plus 1, I set it equal to 0. That says 2x is -1, x is -1/2, so there's one number. Then I have 3x plus 4 is 0. So 3x is -4. X is -4 over 3, so there's my second number. All right, so on a new screen, you can see I wrote everything in again. So I put on my 2 points, -4 over 3 and -1/2. So I have 3 intervals, -infinity, -4 over 3, -4 over 3 to -1/2, -1/2 to infinity. Now, both of these numbers came out of the denominator, so I dashed them. And then I'm just picking a number. So let's say I pick -2, -1, and 0. But pick whatever makes you happy. Now, a really important thing here is this -5 in the numerator. So no matter what the number is, the numerator is negative. It's -5. Then I put in -2. So -2 times 2, -4 plus 1, negative. 3 times -2 is -6, plus 4 is still negative. So 3 negatives is negative. I think this part with the negative on top is the easiest place to mess up, so make sure you're paying attention to if I have a constant, was the constant positive or negative? So the same thing in the next one. Negative on top. I have -1 times 2 plus 1, negative. I have 3 times -1 plus 4 is positive, negative, negative, positive. Last one, I put in 0, -5 is still negative. I have 0 plus 1, positive. I have 0 plus 4, positive. Negative over positive is negative. Well, what did we want? We want a positive answer, which is this middle part. So this says this inequality is only true for this small little interval of -4 over 3 to -1/2. These take time, they take patience. If it confuses you to do all the little negative positives I do, you can write out each little piece, like that works too. I'm a little lazy, I don't like to write all of that, so I just show it in little pieces of the sign. That helps me out a lot. So good luck, see you in the next video.